I mean, all the real numbers that we know live here. Good. So where can it be? It must be off the line. Okay. So now here's the genius thing. If it's off the line, you know, it's orthogonal to this. So let's draw a line in this direction. This line is orthogonal to the real axis, right? So this axis here is real. This axis is imaginary. Right? I mean, this seems like total hocus pocus, but it's actually a really nice way to. So this means, I mean, for instance, I, which is the, you know, I, the imaginary unit. Okay, the thing that gives me, when multiplied by itself, gives me -1. I can put this here. Okay, so there's absolutely no contradiction. When I said earlier, there is no number that solves that equation. I talked about the real numbers, which are along this line here. Right. So graphically, if I now think about it this way, that I've gone off into some different space, then I lives here, 2I lives here, you know, minus I lives here, minus 2I lives here. Okay, so you can sort of see how they coexist. In fact, they sort of span a bigger space. If we started off with a line, now we suddenly have a 2D plane, right, with sort of two coordinates, the real and imaginary axis, and that's exactly what you call them. Okay, so they don't trample on each other, so that they complement each other. They give you a bigger space to operate in. And now here's the real genius. Let's take a number that has both real and imaginary parts. Okay, I mean, if you think of this now just as a coordinate system, which it sort of is, right? I've drawn two axes. So I can go 3 in the real direction, and I can go 2I in the imaginary direction.